Here's another limit problem. There are lots of ways to do this. I'm going to show how to do it using Hopital's rule here. First thing we want to check when we do Hopital's rule is that this fraction, as I try to plug in 0, goes to 0 over 0 or infinity over infinity. Notice, if I make that 0, I get 1 over 5 squared, which I subtract 1 over 5 squared from. And then in the bottom, I just let h equal 0, right? So the top is 0 because those two pieces are the same after I plug in h equals 0. Bottom's clearly 0. So first I can definitely use Hopital's rule or try it. So remember, with Hopital's rule, I derive the top and the bottom individually, and then try to reevaluate the limit. So I'm going to draw an arrow, write hop so I can indicate what I'm doing, equals, do not drop my limit notation. So one thing I'll point out with this is that you may be bothered by the fact that this thing has h's and not x's. And that's totally fine. It's kind of like standard for us to use x's in our equations and all this stuff, and h's seem kind of foreign. If you want to do this with just x's instead of h's and then do the whole process because it makes more sense to you, that's totally fine. But I'm going to go ahead and do it with h's. So I'm going to talk about this piece and that piece first. This piece, the h, when I derive it with respect to h, just derives to 1. So I put a 1. This piece derives away. So the only question is, what does this piece derive to? I'm going to figure that out and put it up here. So I want to take 1 over h plus 5 squared and derive it. Well, actually, undo. I want to derive it with respect to h, but in order to do that, I'm going to change the way that it looks. So I'm going to write it as h plus 5 to the negative 2 power. So at that point, I can do power rule with a tiny little bit of chain in here. So I am now going to dh this, derive it with respect to h. That gives me, power rule gives me negative 2 times, which is that power rule, to the negative 3. And then this guy just slides in there like it would for any chain rule. So I get h plus 5, all raised to negative 3, with that 2 out front. Now, I'm going to rewrite that so that it's easier to evaluate. I get negative 2 over h plus 5 cubed. Come on. Okay. So from here, a couple things I want to point out about the move from here to here. You may say, oh, I did the negative 3 power, and I moved to the bottom, and this is here, so that should go to the bottom too. Some people want to put a 2 right down here. Well, notice the 2 does not have that negative 3 on it, so only this stuff with that negative 3 power on it moved to the denominator. So that's why this is here and the 2 stays up top. So that's now in a form in which I can evaluate. So I'm going to write negative 2 over h plus 5 to the third. Divided by 1 does not change this thing. So I am going to just plug in my h equals 0 and get negative 2 over h plus, 0 plus 5 cubed. And then the dividing this 1 in doesn't change anything, so I'm not going to write it because it divides out. And then that just gives me negative 2 over 5 cubed. And you should know that 5 cubed is 125. And that's my answer.